All right, for today, this is on the top of this. It's also at the end of your last notes. Find the sum of each of these two series. I'll give you 3 minutes to try it on your own, and then we'll go over it. Uh-oh. At the end of the class, give that one to me, unless it dies before that. Yes. I am actually out of pencils. I might have a pen if you would like a pen. I might have a pen. No, I have cleaned out. We might have to ask a friend. A pencil. Oh, wait, I do have a pencil if you want. Yeah? Yeah. Yeah, quiet down. Oh, it's loud people in here. Yeah. Today is going to be an exciting day because of how much we have to cover. Or did I say have to? How much we get to cover. How much we get to learn today. So much learning is going to happen. You'll be like learning so much, you'll just be thrilled from start to end. And then I believe Friday should be a work day. We'll see. The idea is to do the whole lecture today. Friday's a work day. All right. To find the sum of this series, it's probably actually easier to do it by hand than to type this into a calculator, since you only have to do like 4 numbers. If you plug in your starting number 1, then this would be 5 over 10 to the first, which is a half, plus next number would be 2, 5 over 10 squared, which is what, 5 divided by 100? 0.05. Actually, it might make more sense if I label this 0.5. That's a good idea. And then 5 over 10 to the third would give us 0.005. And then 5 over 10 to the fourth would give us 0.0005. Why do we stop at 10 to the fourth? Right there, that tells us the ending number. So that if you add those together, you get 0.5555. If we continued that not to 4, but to infinity, what would we end up with then? Yeah, it would just keep going, right? Do the 5s get sloppier as you keep going? No. No, they don't. Each 5 is more perfect than the last, especially this one.
Especially that fourth to last one.
That one's a good 5 right there.
No, that fourth to last
This
one.
one,
Yeah, that one's good. That one's good.
this one is a fine 5. If someone saw that with no context, they would know it's a 5.
Yeah, for sure.
Yeah. 5. Ready? Does that make sense? Love it? All right, I'll give you a different way to solve those problems today. Well, you don't have to write it all out and look at what is happening. Anybody need more time to write? All right, and today we're gonna do just 5 things. Sequence notation for, wait, this is not it. This is not it at all. I wonder why they didn't copy over. Hold on. Are you holding on? Okay, hold on a second. This one. Cool. Okay, here's what we're doing today. Just 4 things. Recognize, write, and find the nth term of geometric series and arithmetic series. Find nth partial sums. Use arithmetic to find what? Find sums of infinite. Yeah, what? Find sums of infinite geometric series and then use them to solve real problems. That's what we're doing today. Okay. First thing, what is an arithmetic sequence? You've actually probably dealt with these before. That is a sequence where for each number in the sequence, you could get to the previous number or the next number with this common difference we call D. So you're either like adding or subtracting the same number each time in the pattern. Would you like to see an example? Let's look at an example. So for example, the sequence a sub n equals 4n plus 3 is an arithmetic sequence, and it has a common difference of 4. The first term, 4, 1 plus 3, is 7. The next term, 4 times 2 plus 3, is 11. The third term is 15. The fourth term is 19. And you can see what's happening at each one is you're adding 4 each time. So each pair of numbers in this has a common difference. Any pattern where you add the same number or subtract the same number each time is an arithmetic sequence or pattern, which is a big deal on the ACT. They always ask you about either an arithmetic or geometric sequence. It's only like 1 or 2 questions on the test, but there's always those 1 or 2 questions. So if you understand what that term means, that's just usually 3 points. Really just a vocab question. Usually they'll phrase it as find the next or find the 6th term in an arithmetic series that goes 7, 11, 15, and 19. And then you have to know, because it's an arithmetic, that's a common difference. That helps you find the pattern of plus 4 each time. And then you need to keep adding 4 until you get to whatever one they ask you to do. Does that make sense? You picking up what I put down? Well, let us see if you really are picking up what I put it down. So here is another arithmetic sequence. A sub n equals 3n minus 1. Tell me what the first 4 terms are and what is the common difference. I'll give you 3 minutes, though you probably only need 2. With that extra minute, you can just plan what you're going to do for dinner tonight.
Whoa. We're not even at lunch.
Yeah, I know. But lunch, okay, plan what you're going to have for lunch today with that extra minute.
Cold medicine.
Yeah?
Oh my gosh. Actually, that's gonna be
Because it's the first day of December, I will, as a generous spirit, give you the first term in the sequence. You're welcome. All right. Walk around. If you're stuck, need any help at all, just stop me as a walk. I'll help you till you're so helped you wish you weren't helped so much. All right. All right. What's going on? Now plug in two. That's good. There. Yeah. Max, all right. Yeah, that's good. That's right. Yeah, that's right. Oh, you only did 3 instead of 4. You can add that. That's right. And then how much do you add each time? 2 to 5, 5 to 8. Yeah. What's the common difference? What do you add each time? Yeah. 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 What happened? Somebody beat it.
That's a bird.
Spaghetti. That's right. I guess we don't need to go. I just thought, like, well, I'll do it for the recording image. All right, so you should have got that if you plug in 2, you get 6 minus 1 is 5. If you plug in 3, you get 9 minus 1 is 8. If you plug in 4, you get 12 minus 1 is 11. And then the common difference each time is +3. Huh. I wonder if there's a way we could have found that without writing out the pattern. It's right there. Do you see that? Do you see that? Right there.
Oh, that's crazy.
Isn't that crazy?
It's kind of crazy.
It's kind of crazy. So we could use that pattern to write any arithmetic sequence by this formula right here. Any arithmetic sequence can be written in this form where a sub 1 is your initial value plus n minus 1 times your common difference. Or if you want to think, maybe it might be more useful to you to write it like this. It might be more useful to write it like that. Actually, I take it back. It might be more useful to write it like this. You ready? Final answer. This is my favorite way to write this. Any arithmetic sequence could be written like that. Nope, one last change. Okay, this is it. Final answer. Now I'm satisfied. This is it. Everything I've written so far is equivalent, but I think this is my favorite, where D is like your slope, and then your y-intercept is your initial number minus D. It's basically a linear equation where your common difference is your slope and your y-intercept is the first term in the sequence minus your common difference. You could also write this recursively as your first number is whatever the first number is. And then to get any other number k, you take the previous number and you add the common difference. So I think you could write it as this first box, this second box, or I don't know if it asks you to do it. I think it only asks you to do it once on Webma's side, but you can write it recursively like this. I am holding up. If anyone wants to go for it, too bad. We are at a stopping point. It does say A1 minus D. The next example I'll show you will hopefully clear this all up. Then you'll be like, oh, okay, this makes perfect sense, Mr. Lake. Anybody need more time to write? Doesn't look like it. Okay, let's do it. So for example, we want to find a formula for the nth term of the arithmetic sequence whose common difference is 3, d equals 3, and whose first term is 2, a sub 1 equals 2. And then after we do that, what is the 10th? Well, we know that the formula will be dn plus our first term minus d. So our formula would be 3n plus 2 minus 3. Are simply 3n minus 1. I'm holding up. I'm not even done myself. Because we still have to find what the 10th number of the sequence is, don't we? Yeah, Mr. Lake, we do. I'm so excited to find out the 10th number of the sequence. I wonder what it is. Well, you don't have to wonder any longer. You just plug in 10, right? And you get the answer, 29. Isn't that shocking? Did you ever think you were going to write the answer as 29 in a math class? Such a weird number. But it's 29's time to shine right now. That's the 10th number in the pattern. Right?
Yeah.
Right. I know what you're thinking to yourself, Mr. Like, how am I going to memorize this formula for an arithmetic sequence? And remember that it's dn plus a sub 1 minus d. Easy. You don't memorize it, you tattoo it on your hand. And then you have it forever, right on the back of your hand.
On the back of the palm.
I have it tattooed on the back of my hand.
Do you?
But I use
Invisible ink?
no black light ink. So it only shows up when I put a black light on it.
What if you don't always have a black light
What am I? Okay. What if I don't have shoes on me? What?
on? What? You're right, that was a silly
That's
question.
a silly question. Why would I not have a black light on me?
Yeah, what kind of question? Watch this. Yeah.
Yeah, come on.
Come on.
All right, questions about this? Anybody need more time to write? You ready to do it on your own? You excited?
Not excited.
This is so crazy. Try this one. 3 minutes. First person to get it done gets a free black light.
Your black light?
No, it's, to be honest, don't question where it comes from. It's free. Right? Don't look a gift horse in the mouth. Also, don't bring it around any of the science classrooms. You might get in trouble. The free black light. I'm just saying, don't show it to anybody in the science classrooms because they might be like, hey, isn't that mine? Why do you keep stealing our black lights? Did you get that from Mr. Lake? See, you don't want to answer those kind of questions. What do they use their black lights for anyway, if not to tattoo formulas on the back of their hands? Sometimes I think I'm the only sane teacher in the school. Yeah. All right, I'm gonna walk around. If we are stuck it up, just stop me as I walk by, and I'm stuck. Stuck. You can simplify that if you want it. You could. You don't get paid for simplifying stuff. Yeah, there's time to price. Don't get this. What's up? Yeah.
On Monday, while you're running straight.
All right, well, let's use the formula. Oh, that's not formula. It is a sub n equals. And D, actually D. Plus a sub 1 minus. What is D?
You get bent into all these weird positions.
I think it's a bit. I'm like,
No,
it's a bit.
that is illegal.
Five. The common difference is 5. What case of what? Negative 1. So then our formula is a sub n equals
Like a deep bite.
Oh.
5n
Like it could break like your blood.
plus. All right. Negative 1 minus.
I'm just a little disappointed that I'm gonna get a black eye, which actually that's well, it's during wrestling, but I'm like this. Wow.
So it's just your common difference times n plus initial term minus the difference.
Like, you know how you like get a
And then you just multiply.
I saw it coming. And I try to read it, but I know it's just
Good job, Mal. That is right. Yeah, that's right. That's right. That's right. Okay, I didn't get a chance to check with everybody, and also I did get a chance to give out some free 5-star points. And I know you all get cranky when you don't get 5-star points. So to help us out is 1, 2, 3. Is Nolan? All right. What is the common difference? What is the first term? All right. So if I write my formula, what do I write? Hot dog, which is really just 5n minus 6. What's the 10th term in the pattern? It is 44. 44. I think one paper said 49 and I didn't catch it. If you put 49, change that to a 44. Thanks, Nolan. Happy with that? Okay, you ready? So far, hopefully you found today's class to be challenging but doable. A refreshing level of difficulty. And I know what you're thinking. When are we going to get to the hard stuff? Let's do it right now. The 4th term of an arithmetic sequence is 20, and the 13th term is 65. What is a formula for the nth term? Bum, bum, bum. 3 minutes. Bum, bum, bum. That's a good question. How would you do that? Just think about it.
Figure it out, let me know.
I wonder if there's a way we could find the common difference.
Yeah, when is that?
Wonder.
Be like, D equals what? Essentially. What's the D? Oh my gosh, it's 5. I am so smart. Sorry, I
Ah.
just gave away to everybody.
And then once you know what D is, can you tell me what the first term of the pattern is? Is it? I think it is. And then write your form. I probably gave those hints too quick. We still got a minute here, 45 seconds. Pretend like you didn't see those hints and struggle with it some more. Then look at the hints once you've struggled.
And we'll have them bring you to shut off the answer.
Yeah,
I got
It's-
excited.
I told you it's exciting. You're like, oh no, it's not. Yeah, it's exciting. Look at these problems. These are good problems right here. I was actually just helping a student today with a geometric series that they have for a call number final.
I'm really interested in this.
It was. All right, let's do it. Does everyone see how this came into existence right here? The 13th term will just be the 4th term plus the common difference so many times, right? You just got to add D a certain number of times and then you'll get from the 4th to the 13th. How many times do you have to add D? Well, 13 minus 4 times or 9 times. Right? It might help you if you draw it out. Like here's the 4th number in the sequence. To get to the 13th, I just do plus D, and then that'll give me the 5th, and then I'll do plus 2D, and that'll give me the 6th, and then a plus 3D will get me the 7th, and then so on and so forth, right? So in total, you just add D 9 times, and you'll get to the 13th number. To solve this for D is 2 steps, subtract and divide. If you subtract, you get 45, divided by 9 is 5. And then to go back, if this is the 4th, then the 3rd number would be 15. The 2nd number would be 10. And then the 1st number would be 5 also. So then we just use that formula. 5n plus 5 minus 5. D, A sub I, D. And then you get that the final formula is 5n. And then we could use that to find the 90th term if we wanted, or the 122nd term. Isn't that great? That's a good problem right there. All right, anybody have questions or need more time to write? I think there's one of those on the homework. All right. The next thing we're gonna do is a famous problem. This was given, we talked about it before, but this was given to Gauss when he was in the 5th grade to find the sum of the numbers from 1 to 100. And he did it, I believe, in a minute. I'll give you 3 minutes. What is the sum of the first 100 integers?
Wait, so it's like 1 plus.
2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, all the way to 100.
Is there a shortcut?
There has to be, right? There has to be a shortcut.
We quick on the numbers. Why are you pulling me all the way? Because I keep, yeah, I keep.
It's a shortcut. It's really-
I'm just very. Oh, I messed up, and I really.
You got it? What is it? It's 5,050.
Hold on, this whole time?
That's when you look at them, what do you do?
Hold up, I'm lying. Yeah. That's
1 and 100 make 101, right?
the worst.
What does 2 and 100 make? Or 2 and 99 make? 101. What's 3 and 98 make? 101. What does 4 and 97 make? 101. How many pairs would you have if you paired off all the numbers? 50. What is 50 times 101? 5,050. You don't even need a calculator for it. He did that when he was in the 5th grade, with grade school.
That dude crazy.
That dude is crazy. He's probably the best mathematician in human history.
I mean, besides Andrew Lake, right?
No,
Uh,
no. Gauss is
He's better than you.
like, oh yeah, like magnitudes levels better than me at math.
Oh.
Gauss is
I did 2 levels.
genius. I'm probably not as smart as Gauss was when he was in 5th
Are
grade.
you not a genius?
No,
Oh, are you smart?
my mom says it, but then I know she's just fibbing.
She's just fibbing.
She's just fibbing. Another way you could think about it, by the way, and this is how I actually, oh, I went too fast. Hold on. She just be fibbing. The other way you could think about this problem is if you add 1 and 100 together and then take that and divide it by 2, 101 divided by 2, that'll give you the average number. 50.5, right? You take the biggest number and the smallest number, you add it together and divide by 2. That'll give you the average number. And then if you multiply that by how many numbers you have in the pattern, you'll get it as well, right? If the average number is 50.5 and you have 100 numbers, 50.5 times 100 is 5,050. That's how I think about it. Because that's the way the formula is written for the sum of any arithmetic sequence. You take the first number, you add the last number, divide by 2. That gives you the average number. And then you multiply by how many numbers you have. Isn't that cool? No, it's stupid. It's so cool.
It's super.
Oh, super. Okay.
I mean, stupid too.
No, it's not stupid. It's super. It's super. I'm going to go for it. You can quote me on this.
Don't do it.
It's super duper. Yeah,
Wait.
I know. I don't use that often.
Wait, what about like super duper uber?
Super duper ooper? No.
It's not
No.
cool.
Super duper scooper.
No.
Okay.
No. Thank you. You're super duper.
I've never heard of super duper ooper.
Well, you're not living life, then, are you?
I guess not.
It's not.
I need to go out and find something with super duper ooper. Scooper.
Didn't you want to find it?
Yeah. Then I'll come back to class and I'll be like, you know what I just found that's super duper ooper? And you go, not math. And I'll be like, yes. This cool math thing I just found.
Cool math games.
I am skeptical that a lot of those use math. All right, are we happy with this formula? You ready to use it to impress your friends at parties? You just show up to the party and you say, hey, all, have you ever heard of the pattern 5, 16, 27, 38, 49? What's the sum of the first 150 numbers in that pattern? You don't know? Well, let me show you. And this is how you get cool. Okay. All right, first, we need the formula to find the 150th number. To find the formula for this sequence, what is the common difference? 11. That's your common difference. What's your first number? So then the nth number would be Dn plus your first number minus D. Or in this case, 11n plus 5 minus 11. -6. At this point in the trick, they will start walking away to engage with someone else at the party. And you say, no, wait, hold on. It gets better. And if you have to grab their arm, you can do that gently. Okay. Just an arm on the shoulder. Wait, hold on. This trick, if they call harassment, you say, no, it's math. It's fine. Yeah. They'll be okay then. Nobody can resist a good math trick.
Yeah, nobody.
The 150th number is, when you get out your calculator, they might run. At that point, that's fair. Okay, they're gone.
This really would just carry around a TI-84 in his pocket.
Well, yeah, because your normal calculator can't do all the cool things.
So is N how many numbers you have?
N is how many numbers you have. So in this case, we want to do the sum of 150 numbers. So we're going to do 150 times 5 plus 1644 divided by 2. Calculator again.
Oh, I'm starting to walk away.
Well, hold on. Did you know it was 123,675?
I did, because it says it on the paper.
Isn't that shocking?
Yeah, it's shocking.
Isn't that great? The first trick was better with the 1 to 100. This trick is still good though. I mean, if you're at a party and you see somebody pull out a TI-84, that's the person you want to talk to at that party.
They're the one probably least likely to drug you, so.
Yeah,
Drug you or like
yeah.
pull out a PP or something.
You could probably trust them, put your drink around them.
Yes. Because they do math, and all math people are cool. Yeah, yeah. Yeah, sure.
Sure.
All right, you happy with this?
No.
Are you ready to try it? Yeah, this will be fun. All right. 5. Oop, I didn't erase it. It looked like I did. That was a trick of the light. I find, by the way, when you're doing your math tricks, if they start pulling away, just say, I'm not weird, it's math, okay? Let them know you're not weird. That comforts them.
I'm just so confused. Your comfort zone and my comfort zone are a lot different.
No? Don't you ever, if you're talking to some stranger and they say, I'm not weird, okay, that's a person you know. Yeah, that makes you more comfortable, right?
Yeah.
No?
If I
Yeah.
if I didn't know who you were, Mr. Lake, and I was talking to you at a party.
And I go, I'm not weird,
you were
okay?
Like, I'm not weird. I'd be like, this dude definitely drives a white.
I think I see my friend over there. Yep, that's my friend. I'm supposed to go.
I'm like, next he's gonna be asking if I want ice cream or something like candy.
What? No, not that.
What?
No. All right, so I'll scaffold this for you since I'm such a nice guy. Tell me what D is, tell me what the first number is, and then tell me what the formula is. After you have the formula, use that to tell me the sum of the first 120 numbers in this pattern. And then if you would like to do something kind of cool, type this into your type, are you ready? Type this into your calculator. Don't be. Type that into your calculator like we did yesterday.
What do we type for the A?
Math 0. What?
For the A?
For the formula?
Yeah, the A.
That's this. Just with an X instead of an F. Take this thing right here and plug it in right there. Does that answer your question?
What is
Yeah,
AX?
yeah. It's your calculator doesn't have, well, I mean, it does have an N, but why just use the X instead of the F?
But what do we put for
Nothing in the calculator.
So it's
It's
literally
X.
the A? Just write X?
It's X. Yeah.
Okay.
I'll pull it up. I mean, this is the harder way to do it. It's easier probably just to use the formula. Grab a calculator, do math 0, type in all that nonsense. Do you have D? What's the comment? +6? And then you have the initial number? Have you ready to follow me all? Good, okay, and now you do this hammer. Wait, isn't your initial number 6? And that should be -6. Right, yeah, it should be just 6X. Well, I'll cover it up by giving over. The answer is 12N. 2N plus 30.
Yeah, now.
Okay.
Yes. And then you don't have to, this is just for fun. This is what I need. Do this using the formula I just gave. Oh, shoot, I skipped a step, didn't I? You need to tell me what A120 is. Then you can do the formula for summation. I think I want to phone a friend for this problem, a random person in this class. I haven't given up enough 5 circles. Before I do that, I'll give you 30 seconds to frantically look around the classroom for someone who has the right answer and copy it from them.
My money is on that lands on Mason. It's always lands on Mason.
It does land on Mason a lot. Mason and it's that back corner.
I would say Mason and Jacob. I would say I think one time at one time.
I had John first land was this yesterday, I think.
The sixth broke.
You think so?
You can't see it.
1-6, Malachi. All right, Malachi, what is the common difference?
Y'all need to find somewhere else to sit.
6, that's right. What's the first number? Yes.
I thought you were using your mouse this whole time. It's a
Sometimes I
stylus?
switch between two. So yeah, the stylus is better.
My whole life is like a lie.
Well, yeah.
Yeah.
All right, so you should have the formula that is just 6n. What is the 120th number in the pattern? Do you know the answer?
Me?
Yeah, you got it? 720. All right, and then we're plugging that into this formula. So again, how the formula goes is you have n right here, which is just your subscript 2. It's just 120. Plus, or sorry, times your first number, 6, plus the 120th number divided by 2. Because basically you take the first number, the last number, add them together, divide by 2, that gives you the average number. And then you multiply that for all 120 numbers you have. The answer should be 43,560. I messed up. I need to share my calculator. To do that, I have to stop sharing this screen. So I guess I'll wait for you to write. But basically, you could also have got this answer by taking this and plugging it in right here. You're finding the sum of the numbers from 1 to 120 of the sequence 6n. But again, for your calculator, it's easier just to use x instead of n. If you type that in, we should get 43,560. Does anybody need more time to write? All right, let's do it. Stop share, reshare, calculator. Math 0. We're doing the summation of x starting at 1, going to 120 of the sequence defined by 6x. 43,560. Isn't that great? Questions? All right, so this one. I think let's take a break and then we'll do geometric sequences, which is basically everything I just showed you, but instead of adding each time, we multiply each time. It's 12:05. Let's take a break till 12:10. Yes. Yes. Yeah. That's okay.
Sorry, we didn't bring those, all your tissues. And your hand sanitizer.
Enjoy. They're there for the taking. All right, it's 12:10. All right, so as I was saying before, the only difference between an arithmetic sequence and a geometric sequence is instead of having a common difference, we have a common ratio. So we multiply by the same number r each time. So, for example, this is an arithmetic sequence, 4 times 3 to the nth. Its common ratio is 3. The first 4 numbers would be, first number would be 4 times 3 to the first, which is 4 times 3, which is 12. Second number would be 4 times 3 squared, which is 4 times 9, which is 36. Third number would be 4 times 3 cubed, which is 4 times 27, which is 108. Fourth number would be 4 times 3 to the fourth, which is 4 times 81, which is 324. And you notice that to get from the next number each time, you just multiply by 3. You're just multiplying by 1 more power of 3. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324, and so on and so forth. Again, notice the pattern that the number right here in the equation is the number that is your common ratio. You see how those patterns work? That makes sense? Picking up what I put down. Does anybody need more time to write? Or are you ready to try one? You can go to the nurse, I guess. Nurse,
Don't say I guess.
I guess. From 12:12, I should, oh, we're from 12:12, probably 6:02. 12:12, December 1st. Oh my, will you see this? It's 12:12 and 12:1. Oh my gosh. You should keep this.
I should forever.
Yeah.
Unless you signed it.
I did sign it. All right, your turn. Here is another geometric formula. 6 times -2 to the nth power. Tell me what are the first 4 terms and then what the common ratio is. I'll give you 3 minutes, even though you probably don't need it. Yeah. Come on, Fran. If you're stuck, I'll just stop you. I'll be more than happy to help. That's always kind of something. That's like 7. Yeah. Okay. Yeah, that's right. So, well, negative. Hey. Negative. Yay. 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 All right. You should have gotten that. The next number is positive 24, right? Because you'll multiply by -2 to the second power, but that's just 6 times 4, which is 24. Next one would be 6 times -2 to the third power, but that's just 6 times -8, which is -48. 6 times -2 to the fourth power would be 6 times +16. Notice how it changes sign, right? Every even power will be a positive number. Every odd will be a negative number. And that's what? Is that 96? It's 96, I'm pretty sure. And then you can see that to get from one number to the next, you are multiplying by -2 every single time. So the common ratio is -2. We've seen that number before. It's just that number right there. You see that? So for Does anybody more time to write? So for any geometric series, you can write it by this formula right here. The nth term in any sequence is just the first term times your common ratio to the n minus 1 power. Which, to be honest, you could also write like this. And this is the way I probably prefer to write it. Does that look okay? Not really.
Is that A1 times R?
That's A1 times R to the n over R to the first. But I would really just write it like this personally. If it was up to me and I ruled the world, I would set this straight. I would write the formula like this. Your first term divided by your rate times the rate to the nth power. Or recursively, basically, you just start at your first number, R, and to get, start at your first number, A sub 1. And then to get any other number, K, you would take the previous number, K minus 1, and multiply it by R. So this is your recursive formula down here. Actually, I don't know if it asks you for the recursive at all in the geometric part of the homework. It might have one question about it. Does everyone see how I got from this step to that step? That's your exponent rules. R to the n divided by R to the first. If your bases are the same and you're dividing them, you subtract the powers, n minus 1. So that's just using your exponent rule there. All right, so for example, let's write the first 5 terms of a geometric sequence whose first term is 3. And whose common ratio is 2. To be honest, it's probably easier just to do this recursively and write the answers 3, 6, 12, 24, 48, and so on. But to practice, our formula, A sub n, would be our first term divided by R multiplied by R to the nth, which for us would be 3 divided by 2 times 2 to the nth, or I guess really that's simplified. You don't need to simplify that anymore. The first term then would be 3 halves times 2 to the first, which is just 3. And then the second term would be 3 halves times 2 to the second, which is just 6. Right, because that's just, we'll work it out. We'll work it out. That's just 3 halves times 4. 3 times 4 is 12, divided by 2 is 6. But again, it's probably easier just to do this recursively. I know the next number is just going to be the previous number times 2. So that the next number would be 12. The fourth number would be 24. The fifth number would be 48. And then 96, and then 100, or 204, and then 408, and then 816, and so on and so forth, right? I think that's how it shows in your guided practice, is just to solve it recursively by just taking the previous number and multiplying it by the common ratio. But the formula is important because what if you were asked to find the 100th number in this pattern? You don't want to do all 99 previous numbers to get to that. You'd like a formula that could just take you straight there. Plug in 100, type in a calculator, get the answer. Questions? Does anybody need more time to write? You ready to try it? All right, your turn. Find the 15th term of a geometric sequence whose first term is 20 and whose common ratio is 1.05. It will be a decimal. It will be a decimal. If you want to round to the third decimal place, yeah. Always go to the third. The first? All right. Third decimal place is right now. We're all the cool kids around here. You round first. You round first. First number is R. And then take those two numbers, A1 and R, and plug it into that formula. And then after you have the formula, plug in 15 for S. All right. Great. That's the first number. Right. Base of 1 is 20. What's R? All right, so now we're going to plug that into the formula. 20 divided by 1.05 times 1.05 to the power. Right? Times 1.05 to the power. Which is calculated. Wait, no. It's on 50. I want the 50. I'm trusting. That's right. You did a first decimal too. Why are you trusting? Oh, you typed it in multiple pieces and then multiple. Instead of all of that. What is it? That should be R, not this. Actually, if you type it in piecemeal, you will get a.
Let me double sanitize your free file.
Oh, I'll say this one. It's just part of divided by.
I'm gonna end up doing something.
I think you just want to type that out.
I'm gonna
Fun.
You more of that.
Because that's from the base formula. 1 second. The base formula is A1 divided by I. We wouldn't have to do that if we take I instead of A1. Well, what?
Oh. Feel better.
Yes, that's right.
Feel better.
To the n, yeah, that's your formula, and then you want to tell me what is that formula when n is 50. Plug in 50 for n, type it into the calculator. Okay. All right, let's go over this. You know who wants some 5-star points? I'll tell you who wants some 5-star points. 2, 3, Mason. All right, Mason, what's the first number in the series? 20. What's the common ratio? So we're going to take those two numbers and we're going to plug it into this formula. So it'll be 20 divided by 1.05. Technically, I guess parentheses around that. Times 1.05 to the n. If I want to find out the 15th number in the series, then what do? Put 15 as n. So this will be 20 divided by 1.05 times 1.05 to the 15th. And you should get that that's about 35.9. Or how do you write numbers? 39.59. And if you round up, 9. Which you should. That's the next number, 6.
I didn't even bother to write. I wrote the whole thing.
You want the whole
I
thing?
wrote the whole thing.
That'll be fine.
Yeah.
I always go to 3 because that's what they want at the AP Calc test. Always 3. Questions? All right. Let's do a challenge question. The 4th term of a geometric sequence is 125, and the 10th term is 125 divided by 64. What's the 14th term? It's 5. Yep. No, wait, not 5. Actually, it might be 5. I don't know. I don't know. I don't remember. Up. To be honest, actually, I take this back. Once you know R, it's probably easier just to tell me what's a to the 11, a to the 12, a to the 13, and a to the 14. That's probably way easier to do. So you could go, after you know R, you either go down there or you go up here. To be honest, telling me the next 4 numbers is probably way easier than going back. And if you look at the previous challenge question, it might help you fill in some of those blanks. Picking up what I'm putting down. Good. Let me check. Yes, yes, it will be.
What? Use water?
No. All right, let's go over it. Did anybody come up? What goes up in this first play? No, close, almost 5. 1 higher. 6. This is 10 minus 4. You just get those numbers right there. If you take 125 and multiply it by whatever the common ratio is 6 times, you'll get to the 10th number, right? Because to get to the 5th, you do 1 time, 6th would be a 2nd time, 3rd would be a 7th time, or 7 would be a 3rd time, 8 would be a 4th time, 9 would be a 5th time, 10 would be a 6th time, or just 10th time. Okay, how do we solve this for R? What's the first thing we got to do? Good, yeah, good question. Glad I asked it, yeah. How do I get rid of this 125? I think someone said subtract, but they meant divide. That's what they meant. So then that gives us R to the 6th is 1 over 64. How do I get rid of the 6th power? You take the 6th root. Yeah. Which in a calculator, it's easier to type in 1 to the 64th to the 1 over 6 power. What is that? What is that? It's a half. And then you could use that to go back and find the first term and then use that to write your formula and then plug in 14 to the formula. But it's probably easier if all we're doing is multiplying by a half each time, right? Then it's probably easier just to take your 10th term and multiply it by a half 4 times. So 125 divided by 64 times 0.5 is 0.976 times 0.5 again, times 0.5 again, times 0.5 again. Oh, I should probably show you how to do this in a calculator. Do you remember how to turn decimals into fractions in the calculator? Math, enter. Math,
Whoa.
enter.
Whoa.
Math, enter, enter. You have to enter twice. Math, enter, enter. And it'll turn that decimal into 1/25 over 1024.
That's crazy.
Type in 0.122070312 math, enter, enter. Will get you the fraction 125 over 1024. Because you just divide it by 2 each time. Yay? Does anybody need more time to write? All right, what do we have left to do? Oh, I know what we have left to do. Finite series. So to find the sum of any finite geometric series, you just use this formula. First number multiplied by 1 minus r to the nth over 1 minus r. There is a proof of that formula that's much more complicated than the one for arithmetic in the textbook, if you would like to read it. It's at the end of chapter 8. we can use that, for example, to find the sum of the first 12 terms of the geometric sequence starting at 1.2 and with a common ratio of 0.3. So A sum 1 is 1.2, R is 0.3, and N is 12. We take those three numbers, you plug it into this formula, type it into the calculator. S of 12 equals 1.2 times 1 minus 0.3 to the 12th over 1 minus 0.3. What? Where'd the 12 come from?
No. That's all.
Where'd the 1.2 come from?
No.
Where'd the 0.3 come from? Where'd this?
Like on this topic, there's just a 4.
In the guided notes, there's a 4. Oh, that's because they rewrote it as the summation using the formula. They went back and found A sub n. A sub n is 4 times 0.3 to the n. Four times 0.3 is 1.2. All right, type into the calculator, you get 1.71. Yeah, but the other way you could do that is, again, to use the summation function of your calculator. X is 1 to 12 times, and then the formula is 1 divided by 0.3 to the 0.3 x. Okay. Yay? All right. Your turn. Do that one. So again, tell me what is A sub 1, what is R, what is N. Take those, plug it into the formula. And it will be a decimal, round to the third decimal again. Your answer should be blank point blank blank blank. For the interest of time, I'm going to start slowly solving this for you. Jay? Okay, then you just find your numbers, plug it into formula, type it into calculator, profit. The last thing we have to talk about today is one last formula. So for geometric series, not only can you sum finite series, but like we showed for bell work and for last week, you can also sum an infinite series. It only works though if your common ratio is less than 1. Or if it's less than -1, if it's negative. The sum of that infinite series then is this formula right here. Your first number divided by 1 minus your common ratio. So for example, for this problem, our ratio is 0.6. Ratio. Our first number in this formula is 4. To find the sum of that infinite series, 4 times 0.6 to the 0 plus 4 times 0.6 to the first plus 4 times 0.6 to the second, and so on and so forth. You could do that by hand and see a pattern like we did for the bell work, but now there is a shortcut. The shortcut is it's just your first term over 1 minus your 8. That is the weirdest looking R I've ever drawn in my life. So it's just 4 divided by 1 minus 0.6, which is 4 divided by 0.4, which is 10. The sum of that infinite series is the number 10. Isn't that wild? This is the sum of 4 plus 2.4 plus, what's 1.44 plus, notice how each term in this series is getting smaller and smaller, right? So as you add those smaller and smaller fractions together, they converge to a single finite number, 10. All right, so your exit ticket today is to try that problem. Tell me what that equals. Yeah? Okay. Note that 5 is your first value, your rate is 0.5, and again, the formula is your first value, 1 minus r. While you do that, let me tell you a story about, I think it's Zero, Xero, an ancient Greek, who argued that time and space cannot exist because in order for a turtle to get to the end of a rope, it would have to cross half the distance of the rope, right? And before it could do that, it would have to cross half of that or a quarter distance of the rope. And before I could do that, I would have to do half of that section. So an 1/8 and a 1/16 and a 32nd. And that is an infinite number of numbers. And it's impossible to cover an infinite space. So it's impossible for the turtle to get to the end of the rope. But yet in reality, it looks like the turtle walks and meets it there. So as a result of that contradiction, time and space must not exist at all. He was a pretty crazy dude. He just didn't know that the sum of finite geometric series exists so long as the common ratio is less than 1. But now we know that. So you could go back into ancient Greece and be like, hey, guy, no, you're just crazy. It works. Let me show you my math work. The answer was 10 again. You never expect it to be 10 again. Thank you for reminding me. We'll do the application as bell work for Friday, and then Friday will be a work day. The homework is not due out until Monday. I just ran into the.
I don't think progress in pickleball. Fair enough. It's like tennis. That's funny.
Not zero, Zeno. Sorry, ZNO. Not zero, Zeno. See the turtle?